In this lecture, we will see some basic concepts which are required while you solve the capacitor problems. Few things which one has to keep in mind while solving capacitor problem is that the two plates of capacitor will always have equal and opposite charge. So if one plate has plus Q, another plate will have minus Q. That is one thing. If the plates of capacitors are joined like this, suppose let us take three capacitors. These plates may be connected to battery or some other battery may be here. So the plates which are connected to battery are getting some charge and they are getting charged. The other plates which are not connected to battery will have charge which is opposite to these plates in relation to the other plate. And one important thing of these isolated plates, isolated means they are not directly connected to any circuit giving the charge through battery. So these isolated plates will, the sum of the charges, that is the algebraic sum of all the charges of the isolated plate will be 0. This is very, very important. And the third point you should remember is that battery will give equal and opposite charge. If this side gives plus Q, the other side will give minus Q to the circuit. So by using these 3 points, point number 1, equal and opposite charge on the plates of capacitor, point number 2 is summation of the charge on the isolated plate has to be 0, and point number 3 is battery will give equal and opposite charge. Now let us use that concept to solve one of the problems which is there in the Aerodove book also. Let V be the voltage of this battery. It is connected to two capacitors. We have to find the potential difference between point A and B. Now apply that concept. Suppose battery gives plus charge here, so it will give minus charge here. Plates will have equal and opposite charge, so this plate will end up having plus Q. This plate will have minus Q. Now Q is equal to CV for any capacitor. So if we take point 1 here, point 2 here, so V1 minus VA. Start from the side which has positive charge. This side is positive, so this will be higher potential. V1 minus VA would be equal to the charge on the plate. We take the positive side. We have started from here is Q upon C. If we take this as C1 or this as C2, we can do like that also. So it will be Q upon C1. We know this is higher potential, this is lower potential, so V1 minus V2 we know is V. Now come to this side, start from the positive side. VB minus V2 would be equal to Q upon C2. Now we can easily find VA minus VB if you use these equations in the right way. Now if we take these two equations and this equation also, so if we subtract this is 1, this is 2, and this is 3. Subtract equation 2 from equation 1, you get V2 minus VA is equal to Q upon C1 minus V. Now you have another equation, VB minus V2 is equal to Q upon C2. Now add these two equations, you get VB minus VA is equal to Q upon C1 plus Q upon C2 minus V. So this will be the voltage difference between VB minus VA. So if C1 and C2 happen to be equal, which is equal to C, it will become twice Q upon C minus V. Will be the potential difference between VB and VA. So this way you can solve the capacitor problem. This was not so difficult. There can be other problems which are more difficult in nature, but the three concepts if you apply, then the difficult problems also one can solve.